Welcome back to the chapter Triangles again. In the spirit, we will solve few examples related to inequalities in a triangle. Let's see the first question. Show that in a right triangle, the hypotenuse is the longest. Right triangle, one of the angles is 90 degrees. In a right triangle, can we have, or in any triangle, can we have more than one 90 degree? Let us see how does it go. In a triangle, we have 3 angles, and the total of any triangle is 180 degree. 90 plus 90 itself is 180, so the third angle should be 0, which is impossible. So maximum 90 degree in any triangle is 1. So we can only have 190 degree, and let B be the right angle. Let angle B is equal to 90 degree. And angle A and angle C are less than 90 degree, or they are acute angles. So 90 degree is the largest angle. Therefore, 90 degree, which is angle B, is the largest angle. And by theorem, we have seen that the side opposite to 90 degree is the side opposite to largest angle is the longest. Therefore, AC is the longest side, because side opposite to larger angle. So we can say that hypotenuse is the longest in any right triangle. Let's see the next question. Sides AB and AC of triangle ABC are extended to P and Q. PBC is less than QBC. PBC is less and QBC is more. Let us take this as 110. So this will be 120, just as an example to understand better. At the point B, it's forming a straight line. So this should be 70 degree. At the point C also it's forming a straight line. So this angle should be 60. So what can you understand from this? At a point, if one side is smaller, then the other side will be larger. So let us write down. Angle PBC is less than angle QCB will give us angle ABC is greater than angle ACB, because both of them are forming straight line. Because angle ABC plus angle PBC should be equal to 180 degree linear pair or straight line. Same way, angle ACB plus angle QCB is also equal to 180, same reason. To write this way, it will be harder, but to understand from here is easy. That's why I just write some numbers so every one of you will understand better. But to explain, you have to write the full name of the angles. So we discovered that ABC, this angle is larger and this angle is smaller. So by theorem, the side opposite to the larger angle is longer. Therefore, AC is greater than AB, because that is the side opposite to larger angle. Simple proof, right? That's it, question 3 now. Angle B is less than angle A. B is small and A is big. So let us mark small by a small mark and big by a big mark, which means the side opposite. This will be larger and AO will be smaller. Let us take this as 10 and this is 8, because this is opposite to smaller angle. Again, C is smaller than D. This is small and that is big. which means the side opposite to D. Let's take this is 20 and this is, let's say, 12. So take it together. BC is 30 and AD is 20. So BC is greater. That's what we have to prove. So let's take one by one. Angle B is less than angle A will give us BO is greater than AO. Why? Because sides opposite to larger angle. Next, angle C is less than angle D will give us CO is, which is opposite of angle D. CO is greater than DO. Let's take this is the same reason. This is equation 1 and this is equation 2. When you add 1 and 2, what do we get? BO plus CO. BO plus CO is BC. Will give us BC is, follow the same inequality. AO and OD is AD, which means BC is greater than AD, or just rewrite it, AD is less than BC. That's what we have to prove. Now moving on to question 4. AB and CD are the smallest and the largest sides of the quadrilateral ABCD. AB is the smallest and CD is the largest. We have to show that angle A is greater than angle C. We have to compare between these two angles. So let us take the triangle ABC. In triangle ABC, AB is the smallest from all the sides, which means AB is smaller than BC. Or BC is greater than AB. Why? Because AB is the smallest. So all the other sides of the quadrilateral will be larger than AB. So BC is largest, which means it's longer than AB, which means the opposite. Let's call this as angle 1 is greater than angle 2. So angle 1, which is the opposite, is greater than angle 2 because angle opposite to longer side. So we get angle 1 is greater than angle 2. Same way from the triangle ADC, CD is the longest side of the whole quadrilateral, which means AD is smaller. CD is greater than AD because CD is the largest or longest side. So CD is the longest, which means the opposite to CD is, let's name this as 3. Opposite to AD, let's name this as 4. So we get that angle 3 is, which is the opposite of CD. Angle 3 is greater than angle 4. Let's name this as equation 1 and this is equation 2. When you add 1 and 2, we get angle 1 plus angle 3 is follow the same inequality greater than angle 2 plus angle 4. Angle 1 plus angle 3 means it is the whole angle A. So therefore, angle A is greater than angle 2 and 4 is angle C. That's the first proof. Next, we have to prove that B is greater than angle D. So similarly, we will construct a line from B to D, join B to D so that we get the triangle ABD. In triangle ABD, AB is the smallest side because this is the smallest from all, so AD is greater than AB. Again, AB is the smallest. So the angle opposite to AD, which is, let's name this as angle 5. And the side angle opposite to AB, this is 6. So we can say angle 5 is greater than angle 6 because it is the angle opposite to longer side. Similarly, from the triangle BCD, CD is the longest side, so CD is greater than BC. So the angle opposite to CD, which is, let's call this is 7 and this is 8. So 7 is greater than 8, angle 7 greater than angle 8. The same reason, angle opposite to longer side. Let's say this is equation 3 and this is equation 4. When we add 3 plus 4, we get 5 plus 7, angle 5 plus angle 7, follow the same inequality, is greater than angle 6 plus angle 8. And you know 5 plus 7 is the angle B, which is greater than 6 plus 8 is the angle D. And that is what we have to prove. Next, moving on to the last question. PR is greater than PQ. Let's name this as angle 1 and this is angle 2. We know PR is greater, so angle 1 is greater than angle 2 because angle opposite to longer side. PS bisects QPR. PS bisects angle QPR means these two angles are equal. Now we have to prove that PSR is greater than PSQ. PSR is greater than PSQ. This is what we have to prove. Now, to the triangle PQS, for triangle PQS, angle PSR is the exterior angle. And you know exterior angle is equal to sum of interior opposites angles, and these two are equal. So which is equal to angle 1 plus angle A, angle 1 plus angle A. To be specific, we can write angle Q plus angle QPS. Is equal to angle PSR. Now, to the triangle PRS, in the same way, PSQ is the exterior angle. So angle PSQ is equal to angle A plus 2, which is angle R plus angle SPR is equal to the exterior angle PSQ. Let's name this as equation 1 and this is equation 2. From these two equations, we know that QPS is angle A and SPR is also angle A. These two are equal. But we know that angle 1 is greater. Angle 1 means angle Q. Angle Q is greater than angle R, which means when we compare from equation 1 and 2, these two are equal, but we know that angle Q is greater, which means angle PSR is greater because equation 1 is greater than equation 2 because Q is greater than R, which means the right side will also be greater. PSR is greater than PSQ. Since angle Q is greater than angle R. That was to be proved. That's all for this chapter. Hope the ideas are clear. Keep practicing and see you in the next chapter super soon.